Hello everyone and welcome back to C.A.R. Entertainment. I am your host Dylan Hamilton, guys, and today we're going to be moving on to another topic of AT1 biology. We've done homeostasis in the kidney and we've done immunity. Now we're going to move on to neurons, guys, or otherwise known as neurological physiology. So let's get straight into this here. Neurons comes in, we go through neurons, the nerve impulse, and all that there jazz. So let's get straight into it. So a basic introduction that tells you about the nervous system. Well, the nervous system is based on a system of neurons that transmit electrical nerve impulses throughout the body. There's fine control that is integrated, fine control integration, and this is provided through the system of synapses which are between neurons that control nerve pathways, and we have a separate video on synapses that will come later on. Now, nerve control is faster and more precise than hormone action, with nervous control involving receptors and effectors with interlinking coordinators. A receptor will be sensitive to a particular type of stimulus. So essentially, a receptor would be maybe like a fingertip, or like touch. So you have touch, smell, hearing, stuff like that. There's your senses. There are your receptors, and then your effectors are your muscles, your reaction, and then your interlinking coordinator are your neurons within the body, and we'll talk about those now. So the central nervous system, like we just said, stimulus is someone we hear, see, and smell, etc., and effectors will produce a response, and these are often muscles. Now, coordination is invariably involved in the central nervous system, and this comprises of the brain and the spinal cord. There are many neurons which travel to the CNS from receptors, and there's also from the CNS to the effectors. Now, these types of neurons are as follows. You have the motor neuron, which carries impulses from the CNS to the effectors. You have the sensory neuron, which carries impulses from receptors to the CNS. And then you also have the connector and relay neurons, which connect neurons with the central nervous system. Take a look at the diagrams below, and they will give you a good indication of what they all look like between your motor neuron, your sensory neuron, and an interneuron is otherwise known as a connector neuron. The different descriptions then. Well, a cell body, which you can see is within these diagrams, contains a nucleus, mitochondria, and other organelle cells such as Nissel's granules. They transmit impulses away from the body, known as an axon. So an axon will transmit an impulse away from the body, with the dendron will be a fiber that carries an impulse to the cell body. A dendrite are a very small extension which conduct impulses into the dendron or into the cell body. An axon will terminate in a synaptic bulb. Nerve fibers will be myelinated, as the dendron and axons are covered in an insulated myelin sheath, which is formed of greatly extended cell membrane of Schwann cells. These Schwann cells are arranged at intervals along the nerve fiber with small gaps in between them called nodes of Ranvier. These nodes are at the dendron and the axon, meaning they're exposed. So these nodes are exposing the axon and the dendron. The myelin sheath, though, is protecting the function, and it serves to speed up nerve conduction through saltatory conduction, and we'll talk about that later. So what are the adaptations of the motor neuron? The motor neuron is one you're probably going to be asked more on. So what are the adaptations of it? Well, they have highly branched dendrites, which increase the surface area, and therefore synapses are made with all neurons to receive incoming impulses. There's also many mitochondria in the cell body and the axon, which provide ATP, which is needed to maintain resting potential. Long fin axon, as they provide pathways for the nervous system to conduct impulses over a long distance. And then you have myelin sheath, which is an electrical insulator which prevents the formation of action potentials and speeds up conduction as the nerve impulse jumps from node to node. You also have nodes of Ranvier, which we previously talked about, which are gaps in the myelin sheath, and this absence of myelin sheath is essential, allowing an action potential to form. The branch of the terminal ends of the axon increase surface area, and the axon can form synapses with the effector, and finally a synaptic bulb will transmit impulses to an effector. So potential differences. We mentioned this thing called an action potential in the nodes of Ranvier there. So let's actually go over what actually is this. Well, a potential difference is caused by a difference in electrical charge on the inside of the plasma membrane compared to the outside. So you're always comparing it to the outside. So if we go all the way back here and we look at the motor neuron, you see inside the actual axon. You see the axons, the black line that are going through the Schwann cells. Inside that there, we have electrical charges, and on the outside we have electric charges. Now, when the neuron's in resting and there's no impulse, then both sides will have a positive charge, but the inside is less positive than the outside. So essentially, they're both positive, but the inside is lower than the outside, essentially. So inside is known as minus 70 millivolts compared to the outside. It's still positive, but it is negative 70. It's down by 70 compared to the outside. Now, An animal cell's potential difference will be across the plasma membrane called polarization, or it's polarized. So a potential difference across the plasma membrane polarized, as it's become polarized. Now, neurons and muscle cells and receptors will be excitable. This potential difference is reversed in a process called depolarization, where the potential difference is decreased and cancelled out before it's reversed. Potential differences can be set up due to unequal distribution of ions. Thanks for watching this video on neurons, guys. Our next video on the nerve impulse will go in depth into this here on how ions work and all that there, and how energy potential is generated. So stay tuned for that there. I've been Dylan from C.A.R. Entertainment, and I'll see you next time.